Lesson 7.9, average rate of change, part 2. All right, so the second page. Here we have comparing two graphs on the same axis. So we have a school has two buses that take different routes to drop students off. They leave at the same time. So they're both leaving at time 0 from school. School's over. And then we have f of t, the dotted line, and we have g of t. So they're taking different speeds at different times, like f of t, this bus is stopped at this point between 2 and 4 minutes, it looks like, right? This must be another bus stop here between 5 and 6 minutes. They both reach the same point, distance from school, looks like 5 miles from school, right at 12 minutes. And then they both come back to school. They both come back to distance 0, so they return to school, but one returns before the other. The f of t returns before the g of t bus. So you're going to answer questions. Select all the true statements. We'll do a couple together. Is f of 2 equal to g of 2? So let's look at that. Here's 2. That means 2 at 2 minutes. F of 2 is the distance of bus F at 2 minutes. So that's the dotted line here. Erase some of the lines I've made. So the bus there is 1 mile from school. F of x is 1 mile from school. And this bus, g of t, is about half a mile from school. So that is not true. Those are not equal. Let's look f of 15. So at 15 minutes, here we are, is f of 15, so the distance of bus F, has it gone farther from, is it farther from school than the G bus? Yes, it is. That's 3 miles from school, and f of 15 equals 3, and G of 15 only equals 2. So that is true. F of 15 is greater than G of 15. So you're going to do these 3 yourself. So you're looking at f of 10 and g of 10. So at 10 minutes, are they equal? Are they the same distance from school? Is that true? I think there's just one more true statement in this section. And then another thing, all the true statements. Let's do one together. Do f of t and g of t have the same maximum? So here's the maximum right here. They do have the same maximum. That is true. They both have a maximum distance of 5 miles from school. And then there's some questions about increasing and decreasing. Remember, increasing is when you're going up, generally. That's increasing. So from 4 to, it was a big section here. I guess technically it would be better to say like this is increasing, but when it's flat here, that's not increasing. Let's look at this interval here. F of t and g of t are both increasing from 4 to 5 minutes. Well, f of t is increasing, right? It has a positive slope, but g of t is not increasing. It just has a 0 slope. It's stopped at that point. So that is not true. Okay, and then you have to choose one value where f of t equals g of t. Where are they both the same distance from school? Okay, last part of these notes is a simple formula for distance, rate, and time problems. The distance equals the rate times the time. And so d equals rt. D equals r times t. And this makes sense with units. If miles, let's say we're doing it in miles, the number of miles equals the speed, so let's say miles per hour, times the time, times the number of hours. And we can see here's a compound unit, right? It's a fraction, miles per hour, and here's just a simple unit, hours. If we were to multiply these two together, we could put hours over 1, and the hours would cancel. And then that would make sense. We'd have the number of miles equals the number of miles. So let's try some problems here. And we'll go back to those after. So how long does it take for a boat to travel 40 miles at a speed of 27 miles per hour? So we can use our distance equals rate times time. And we have 40 miles. That is a distance. 27 miles per hour is a rate. Rate is also speed. Another word for rate is speed. So let's plug these things in. So we have 40 miles equals 27 miles per hour times time. So we can divide both sides by 27 to get t by itself. And then we get the time equals 40 divided by 27 is 1.48. Now we have to put the units, so it's time, and we have to look at what the time units are in this problem. Well, it's miles per hour, so time isn't going to be in hours, not minutes or seconds. That last one here, we're going to use our same formula, d equals r times t. And we have a speed, 22 kilometers per hour, that's a rate, and we have a time. And we want to get distance. So distance equals, I'm going to leave the units in this time. We'll see how the units cancel. Kilometers per hour. Now, this we have to do something first. This is in minutes, and this rate is in kilometers per hour. So we have to convert that to hours. You have to make sure your units are in the same form. So 5 minutes equals how many hours, right? So we can do some division. We can say 5 minutes divided by 60 minutes in an hour is going to give us the fraction of an hour, and that is 0.083. So now we're going to plug in our time is 0.083 hours. Now notice here, this is a whole number, I can put it over 1. The hour unit and this hour unit will cancel because they're diagonal from each other. And so then we're just doing 22 times 0.83, and that equals 1.83, and then our units, it's a distance. And the distance units in this problem are kilometers, so it's that many kilometers. Okay, last thing here, you can also solve the equation itself for one of the variables, so we could solve for r. To get r by itself, we would divide both sides by t, so rate equals distance divided by time, which makes sense. That's what we talked about on the first page. Rate or speed is the distance divided by the time, like for instance, miles per hour. It is also in our graphs, it is the slope, right? On page 1, the slope was distance over time. We can solve this, d equals r times t. We can solve for t by dividing both sides by r, so you could also say time equals distance divided by rate. Now notice, distance equals rate times time is also a linear equation in the form of y equals mx plus b, the slope. So our y is distance, and that makes sense, like on the other page, the y-axis is distance. So if I have a little y-axis, distance. The x-axis is time. And then the r, the rate, is the slope. And in this case, the y-intercept is usually 0. It's at time 0 and distance 0. Okay.